In this example, they give us the opportunity to solve the equation by eliminating b, and then we have the opportunity to solve it by eliminating a. Just so you can see, you will get the same answers either way. So those of you who would have naturally eliminated b will get to the correct answer, and those of you who would naturally have eliminated a would also get to the right answer. So in part A, they say choose the appropriate whole numbers to multiply each equation by so that the system can be solved by eliminating b. So you'll notice there's no easy multiplication here that I can do to just one equation, but instead I'm going to have to multiply both equations by a number so that the b terms can be eliminated. So in this case, I'm going to multiply the entire first equation by 7 so that I'm getting a common factor in the b terms. And I'm going to multiply the entire second equation by 3. So when I do that, I'm going to get 5a times 7, which is 35a, and 3b times 7, which is 21b, and 3 times 7, which is 21. And my second equation also changes, so it's going to be 9a minus 21b equals, now 81 times 3 is 243. Now look at the numbers you have. I've got a positive 21b and a negative 21b. So they'll naturally cancel each other out if I add everything together. So 35a plus 9a. I've got 44a. My b terms have canceled each other out now, so they're not there at all. And then 21 plus 243, so that's 264. Divide both sides by 44, so a equals 6. Now take that number and plug it back into any of the original equations. It's probably best to go back to one of the original that were written down in your book, just in case you made a mistake at this step here. So let's say 5a plus 3b equals 3. So where I have an a, I'm going to substitute in the 6, and then I'll just have to solve for the b. So when I subtract 30 from both sides, I get 3b equals negative 27, and then divide both sides by 3, so b equals negative 9. Now let's see if we had eliminated the a to start with, if we would have gotten to the same answers. So let's go back to the original. 5a plus 3b equals 3. And 3a minus 7b equals 81. When I look at the a's to try to eliminate them, I can't just multiply one equation to eliminate it. I'm going to have to multiply both. So I think of a common multiple of 5 and 3, and I'm thinking of 15. So in this first equation, I'll have to multiply everything by 3, and the second one, I'm going to multiply everything by 5. So I'll just write that down here. So my first equation is going to become 15a, so, and then 3 times 3 is 9b, which equals 3 times 3 is 9. And my second equation is also 15a minus 35b equals, now punch that in your calculator, 81 times 5 is 405. And then just determine, do you need to add or do you need to subtract? Since I want to eliminate the 15a and the 15a, I want to subtract. Now it's easy with that first term, but pay really close attention what happens to the b. I've got 9b minus negative 35b. So that's minus a negative. That means add. So 44b and 9 minus 405 is actually negative 396. So divide by 44 and b equals negative 9. That's exactly what we got in the first case. So when I substitute that back into either one of my original equations, let's just make sure that equals 81. We'll solve for a here. So that's plus 63 equals 81. And a equals 6. So you can eliminate either variable and you'll still get the same answer.